Worldwide, 60 million petrol tanks are made each year for new vehicles, and millions more to replace old or damaged tanks in existing cars. And considering how much it costs to fill them, it's no wonder today's petrol tanks are made to be tough. Making a petrol tank begins with a simple sheet of steel. It's nickel-plated to make the tank rust-resistant. The steel is placed in a hydraulic press that applies 800 tons of pressure. This compresses the sheet between two dies that shape the bottom half of the tank. The press forces the male die up against the sheet and into the cavity of the female die. To make the top half of the tank, or tanks of a different size, it's simply a matter of changing dies. On the tank's top section, a stamping press imprints information, such as the product and lot numbers and the manufacturer's name. A hydraulic punch then pierces two holes, one for a tube to fill the tank and another to vent it. This machine makes an opening for a component called the Fuel Delivery Module, or FDM, which will send fuel to the motor. A conveyor moves as many as 180 top sections per hour to the next production. There, a steel and nylon jig is used to install a steel ring that'll position the FDM. The ring is spot welded in 6 spots to fuse it to the top section. 2 notches on the ring will align the FDM properly. The top and bottom sections are tacked together and properly aligned for the comprehensive welding that follows. 2 metal wheels compress the sections together and water cools the area, as a machine called a seam welder fuses the upper and lower halves of the tank. Steel tube is fused to the tank using a gas torch and lead solder. This is the filler tube, into which you insert the nozzle when you fill up at the pump. Fuel flows in, and air vents out through the tube simultaneously. A sensor automatically shuts off the petrol pump when the air pressure inside the tube reaches a certain point. Most tanks fill to only about 80% capacity to leave room for vapours caused by hot weather. Robots weld the tanks destined for brand new vehicles, because the work has to be precise and consistent in order to aid the assembly line robots at the car plant. The human welded models are sold to auto repair shops as replacements for damaged tanks. They don't require the same precision because a mechanic does a custom installation. When the robots finish welding the tanks, they transfer them to a conveyor belt that moves them to the next production phase. There, a tin-plated venting tube is attached. Tin makes it rust-resistant. A steel component called a baffle is added to the bottom section of the tank. This reduces the sloshing of fuel inside the tank, resulting in less noise for the driver and less metal fatigue for the tank. They're usually just for tanks found in larger vehicles. The top section is now placed onto the bottom section, and a hose is pulled through the opening in the top. This hose will connect to the FDM. After a welding machine fuses both halves together, another machine bends the sides downward. This gives designers extra space to work with. Each tank is tested for leaks by being immersed in water. All the holes in the tank are blocked and a little extra air is pumped inside. Bright lights aid the search for any bubbles in the water. If air can escape, so can petrol. No bubbles and the fuel tank passes inspection. Only then is it ready for shipping and a starring role car.